Good afternoon, guys. Welcome to the channel. In this episode, we're looking at how matrices can be used to model practical situations, and this term, graphing networks. So this can be also called a graph if you're doing VCE Unit 1 and 2. I'm sure that is not common at the moment, but you may be up to it later in the year and also see it as a module in Year 12. So using a matrix to record the number of ways travelling directly from one town to another. So we've got town A, B, and C. And we want to record how we get from, point A to point B and also point C. Okay, and this can be done, and it's worthwhile in a matrix because once imagine your road network, there are more than multiple, hundreds of ways to get from one town to another in some instances. And this can be one way of looking at all those ways and to solve traffic problems in the long run. So first thing we want to do is create a matrix. Well, what I'm going to do is label towns A, B, and C on my matrix first. Okay, so I'm going to put town A, town B, town C. And we're also going to do it in the columns. Okay, you can see on the right there that there's an example of what one might look like. That's not for this one in particular, but see what it does. Now we start running through and mapping what's going on in the town. So I might just have a look at a different color quickly. Okay, so let's have a look. If we look at from town A we can get to town C right there. So I might go A to C. Before I hit that, let's go back there. We can go town A to C there. We can also go town A to C there. Okay, so there are two ways to get from town A to C. So from A to C, we can put 2 there. Now, the reverse is also true for this. There are also two ways to get from town C to A. So from town C to town A, there are 2 ways. All right, because there's no direction specified in any of this. Now, let's have a look. Next up, from town A to B, we can run along there. Now, there is no other direct route from town A to B. So sure, we can get there in other manners. But there is only one way to get from town A to B. So that there is a 1. And the vice versa is true. So from town B to A is also a 1. Town C, you can see that to get from town C to town B, there's one way there, and there's one way there. And the reverse is also true. So town C to town B, there are 2 ways. And from town B to town C, there are also 2 ways. So you'll notice here that we've got some gaps in there. Now, because there are no loops in the graph, this diagonal, what we call the leading diagonal, is going to be all zeros. Okay? The only way that that wouldn't be a 0, if, for instance, we had a road that went from town A and looped back around to town A, then we would put 1 in there, but we don't, so we're going to leave that now. Rub that out. There we go. Okay. Now we can also do the reverse. We can take a graph, a matrix, and make it into a graph. We can see that this graph is made up of A, B, and C. Okay, so I'm going to start by creating towns A, dot there for that, town B, doesn't matter where they are, and town C. Okay, and start reading the information. Okay, so let's read down from town A. Town A has 1 connection to town B, so we can go right there. Town A has 2 connections to town C. Doesn't matter which way, as long as we show 2 connections. There. Town B has 1 connection to town A, we've already shown that, and no connections to town C, so there's none down here for that one. Town C has 2 connections to town A, we've shown that here, 1, 2, and no connections to town B. All right, and again, our leading diagonal shows us that there are no loops in this diagram. So that is the end of how to draw a graph from a matrix. And you can see that the reverse is true as well. If we go from A, so A to C, right there, it's 2. So they're both, it's all going to end up true at the end of the day. So hopefully that helps you in modeling practical situations from graphing networks to matrices. Okay, see you next time on the channel, guys. Please subscribe, like the videos, send a comment if you want to about how much you love matrices. That would be awesome. See you guys.